Assalamualaikum. This is Rakib ID 22408017. Today I am talking about embedded system, the important topic. First of all, round robin. This is the topic of architecture or operating system. Round robin is a CPU scheduling algorithm where each process gets a fixed time slice called time quantum. And round robin algorithm. Here we see three process P1, P2, and P3 according to arrival time 0 millisecond, 4 millisecond, 5 millisecond. At time 0, P1 process is come and then 2 millisecond it will run. In 2 millisecond, the process is there is no process come because next process is come 4 millisecond. So then next 2 millisecond P1 process will arrive. In 2 millisecond P2 process is come and it will run 2 milliseconds. P2 processes runs 2 milliseconds. Then P3 processes come in 5 milliseconds. So next 2 milliseconds P3 process will come. Then round P1. Here rest in 1 millisecond. So next P1 process is come and run for only 1 millisecond. Here is 9. Then it finished. P2 process is 2 millisecond run, so it is finished. Then P3 process will run last 2 minutes. Here is the Gantt chart. Then the next topic is what is queue scheduling architecture and its main function. Queue scheduling architecture is a method where tasks are placed in a queue and execute one based scheduling rules. The main function of queue scheduling architecture. First of all, task management. So, multiple tasks like sensor reading, processing, and output control are managed in order. Next, priority handling. Important tasks like emergency signal are executed first using a priority queue. Then, efficient CPU uses. CPU always pick the next task from the queue, reducing idle time. Real-time performance helps the system respond quickly to interrupt and real-time event. Prevents task conflict. Control shared resource and reduces race condition. For a simple example, a car system, wheel speed sensor reading, brake pressure control, warning signal. Then the topic is real-time operating system architecture. A real-time operating system (RTOS) is an operating system designed to execute tasks within a fixed time deadline. The main component of RTOS, real-time operating system architecture. Here, first of all, kernel is the core part of RTOS, manage scheduling, memory, and interrupt. Then task manager, task management. handle multiple tasks and performance context switching. Scheduler select which task runs based on priority. Interrupt handling responds quickly to external events. IPS interprocess communication. Tasks communicate using semaphore message queue. Memory management uses predictable memory allocation for fast response. Here we see simple block architecture, application, RTOS kernel, and hardware. Then the topic is what is embedded program model. Oh, it is the method of designing embedded software into tasks or module to ensure proper and timely execute. There have single and multiprocessor system. Now we talk about this topic. Single processor system. Only one CPU execute all tasks. There is common models, superloop models, interrupt driven models, RTOS based model, and characteristics sequential execute. That means uh, one CPU for all tasks like task 1, then task 2, then task, task 3, and so on. Then low cost limited parallelism. Multiprocessor system. More than one CPU core executes tasks simultaneously. Model is parallel processing, master slave model, distributed model, characteristics, high performance through parallel execute like T1 task execute, CPU1, T2 task execute, CPU2, and so on. Complex synchronization. Then the topic is what is that software development process? It is a structured process used to design, develop, test, and deploy software for embedded systems. Embedded software is hardware dependent and often real time constrained. The mainstream of embedded system required analysis, understand what the system should do, identify real-time constraint, determine memory, power, and hardware limitation, analyze customer and hardware specification, system design, define overall system architecture, hardware, software, partitioning, select micro, microcontroller or process, design task structure and communication. Coding. Develop firmware, usually in C or embedded C. Write device driver, configure peripheral, optimize code for memory and time constraint. Testing and debugging. Here unit testing, integration testing, hardware and load testing, and others. Hardware integration. Load firmware into the microcontroller, connect and test sensor, actuator, and communication modules. Verify hardware software interaction. Then verification and validation. Check if the system meets requirement. Ensure real-time deadlines are satisfied. Confirm reliability and safety. Deployment and maintenance. Release final product, fix bugs if found, provide firmware updates when needed. Thank you. Thank you, everyone.